You found the Backup Wrap-Up, your go-to podcast for all things backup, recovery, and cyber recovery. In this episode, we tackle the age-old question, is tape backup dead? The short answer is no, but its glory days are definitely over. Prasanna and I will explain why this happened and how it's probably not what you thought. We'll also explain why the cloud giants like Amazon, Google, and Microsoft are the biggest tape users today, while showing you the 4 key reasons the tape remains unbeatable. If you're thinking tape is outdated, this episode might just change your mind. Let's get into it. By the way, if you don't know who I am, I'm W. Curtis Preston, aka Mr. Backup, and I've been passionate about backup and recovery for over 30 years, ever since I had to tell my boss that we had no backups of the production database that we had just lost. I don't want that to happen to you, and that's why I do this podcast. On this podcast, we turn unappreciated backup admins into cyber recovery heroes. This is the Backup Wrap-Up. Welcome to the show. Hi, I'm W. Curtis Preston, aka Mr. Backup, and I have with me a guy who has never actually used the thing that we're going to talk about in this episode. Prasanna Malaiyandi, at least not in production. You've maybe touched one.
I've touched a offspring of it.
An offspring? What's the offspring of tape?
A zip drive. A zip drive / jazz drive.
Zip drive is a bastard stepchild, not an offspring. I guess that's also offspring. But... Zip drive. Wow, that is a blast from the past.
And a jazz drive. I've used both of those in production.
Yeah, what's that?
In production.
In production. Yeah, I actually, if you go back to the first book that I wrote,
way back in the day.
No, actually, I think it's the second. No, it's I don't know. I can't remember. Anyway, there's a chapter in the book, one of the books that I wrote. I can't keep them all straight. And it's on Linux bare metal recovery. The Linux bare metal recovery chapter in that book is based on doing it with a zip drive. Because it was at that time an affordable thing that you could buy to do,
because the drive itself was cheap, or relatively cheap, and the actual media wasn't that expensive. So
yeah. And we can totally trash talk about the guy that helped me write that chapter, which is my good friend Reed, who I think listens to this podcast.
Hi, Reed.
And he took forever to write that chapter. Like it was like one of 2 chapters that I had somebody else help me write. And let's just say at some point I was like, okay, the rest of the book is done, dude. You just need to write these 10 pages. Hi, Reed. Anyway.
So
see,
I think
got the what was that?
So you have to take it back because I have touched something similar.
What?
I told you. You said you
That's
started off.
That's not similar. That's not tape. That's
What about a VHS tape / a cassette?
VHS. We're going to talk about VHS tape in a minute. We're going to talk about VHS tape in a minute.
So I have to go back further. So I haven't used it in production, but way back in the day, I used to go with my dad to his office, and they had huge machines with tape drives.
The big 9-track drives?
Like that look like reels with the thing? Yeah.
I love that you're describing it like it's like a museum piece. Yes, those would be 9-track drives. So, but did you use them?
I touched them.
You okay. All right, I take it back. He has touched a tape. It's just you grew up in a different era. You grew up in IT in a different era. You also worked at a very sort of, I'm going to call anti-tape vendor.
Multiple anti-tape vendors.
Multiple anti-tape vendors. Yeah. Then meanwhile, I was at the same time, I'd already spent, 10 years or whatever in deep, in tape. And so that's what we're talking about in this episode, by the way, is we're talking about tape and, why it's still not dead, right? Why people think it's dead, why it's still not dead. And, yeah, and that's what we're going to talk about. And to do that, I'm going to start with VHS. You literally you made me think about that. There's some really important, interesting, at least I think they're interesting, technical tidbits that we can take from the design of VHS. So there are, and because I think a lot of people, when they think about tape, they think about VHS.
Yep.
Right? It's the only tape that many people have any sort of experience with. And they're like, oh, it's, it's this, it's that, you have all of these problems. A number of things. One is the substrate quality. The substrate would be the part of the tape that you're actually laying the data on is, miles of difference between a consumer grade VHS tape and, now, if we do go back in time, there was a time where there was a tape drive that you could buy for backups that was exactly the same as a tape drive that was being used in the consumer world, and that would be 8mm video tapes. When there was 8mm
Sony, I think,
video cameras.
Yeah, I think
right?
that was Sony standard, right?
Yeah. There were tape drives that you could buy for the data center that were literally made on the same assembly line as those tapes. But let me go back to VHS and why it's important. One of the things that people, when they think about VHS and they think about tape and they think about the low quality, etc., is they think of like the way audio sounds on some VHS tapes, for example, right? And it's just a chance to sort of explain the two different ways that data is typically written to tape. There's what's called helical scan, and there's linear, right? Helical scan is where you take the tape and you wrap it around a drum that is mounted at a slant, and then it's going to write diagonal stripes across the tape. Linear is the closest to linear that most people would be familiar with is a cassette tape, like an old school. For those of you that remember what cassette tapes are, it's a stationary head that's writing data across. Now, why does all this matter? In order to get a high signal-to-noise ratio, which we want a high signal-to-noise ratio because that means that we wrote the data correctly to tape. In order to get a high signal-to-noise ratio, the tape has to go across the head very quickly. I don't know why that is. It's just the law of physics. I didn't create it, etc. But that's just the rules. So you have two ways to do that. One is you can either do the helical scan method, because that way you can the speed at which the head is going across the tape is determined by the speed of the spinning drum, right? And then the other is you can do a linear method, and the way that you do that is that the tape has to be drug across that recording head very, very fast. And when you don't do that, you get a low signal to noise ratio. Now, let me go back to VHS tape. This is way before your time. But there was a time when you had VHS tape, and the reason VHS took off in the U.S. market was two reasons. One is that somebody bought the entire back catalog of everything, and you could only get older movies on VHS. You couldn't get it on Betamax, right? The other reason why it took off was that the tapes were much bigger and you could fit so much more. And one of the reasons for that was that they would slow down the rate at which the tape moved, and it would you could fit so much more on the tape.
I remember that they used to have.
Do you remember this?
I remember this because there were different modes when you're recording where you could say extended, normal, or whatever it was, and like it would be like 1 hour, 1.5 hours, or 2 hours, or maybe it was like 2, 3, and 6 hours on a single VHS tape.
Yeah, exactly. Okay, now why does that matter? Again, this is only going to speak to some of the older folks that are going to remember this. But when they first started doing that, if you chose EP, right, the extended play, the audio sounded like crap. Okay, it really did. Like you had to choose, do I want to fit a 3-hour movie on the tape, or do I want to be able to understand a 3-hour movie, right? Those were your choices.
3-hour movie, 3-hour movie.
Yeah. What they did was that they moved the audio head onto the spinning drum. And so now the audio is being recorded at the same speed, because when you did EP, the tape was crawling across the recording head, which was fine for the video because the drum still spun and the video was fine, but the audio sounded like crap because, as I was trying to explain, tape has to go across a recording head quickly in order to get a high signal to noise ratio. In this case, you were getting a low signal to noise ratio, which results in data loss, which results in bad audio. And in the computer world, that would be very, very bad.
Yeah.
So what they did in VHS was they just moved the audio head up to the spinning drum, and then that created what was called hi-fi VCRs, right? So that you could get high fidelity audio along with your high fidelity video.
High fidelity at the time, we should clarify.
At the time. Yeah. All of that is to just drive home a really important point when we talk about tape. And that is, we're going to talk about tape and what's good about it. One of the real challenges with tape is that it has to go very quickly in order to write the data. Okay? It cannot go slow. That's tape's primary problem. We'll get to that. And this just drives home that point, right? That tape does have to go very fast. And by the way, it's important to understand that almost all of the digital tapes that are tape drives that are being used in production today, LTO, the T series from what is it now? Oracle. It was Sun, StorageTag, Oracle. Yeah. So I don't think they're not in production, but they're still in use. The T series from them, like the T10Ks, and then the IBM series that are like start with a 3. Okay. Those are all linear tapes, meaning that the tape head is stationary and the tape is brought across it, which means that tape has to go very, very fast when it's recording data. Otherwise, you get data loss. Okay. It's just a really important. It's just you brought up VHS. I just thought I'd use that to illustrate this really important point. I hope everyone found that interesting. If not, we're 10 minutes into the thing and I just bored everybody.
But I think another important thing. So we've also covered a lot of the technical aspects of tape in prior podcast episodes. We even had, what was the guy's name?
Joe Jernicke?
Yeah. Joe on talking about that as well. So if you want to really geek out on tape, we'll add links in the show description.
We'll add some links, in the description. Exactly. So let's just talk about. So first off, I'm going to say some stuff that that might go against. So first off, just a couple of facts. More tape is sold today than ever before. That surprises most people when I say that.
Well,
what do you think about when I say that?
I was surprised the first time, and I can't remember. This must have been like 7-8 years ago when people were saying, and I don't know what the number is now, that tape is still like over $1 billion a year.
Editor's note, $4.4 billion a year in 2024 to be exact, growing at CAGR of $7, 8% per year. Yeah.
Right? Which surprises because everyone always talks about disk, but tape has its purpose, right?
Yeah.
And so I'm not surprised that you're saying more tape is sold today than ever before because we have such huge data sets, right? Everyone's keeping data forever. We're now creating all these large data sets with AI, with DNA sequencing, with all of these other things that require a significant amount. The electron collider thing that creates a huge amount of data, right? And so people want to keep that. You want to put it somewhere. Tape is super cheap, right? It's a great place to store data.
Yeah,
so I'm not surprised.
So more tape is sold today than ever before. It's also an absolute fact that a lot fewer environments use tape for their backups today than they did. Today, it's I don't know what the percentage is, but it's very, very small, right? And if we look at the percentage of people who send their backups directly to tape, that percentage is really small. The main people that I know that are using backups for tape are using it for that second copy.
Yeah. Do you think people are putting less backups on tape because they've adopted disk, they've adopted SaaS applications, they've adopted cloud native, all of the above?
Yeah, all of the above. But it really started with tape. Tape became a real pain in the ass when it was used for backups, right? Because tape is really bad at incremental backups because, again, incremental backups go slow. Tape can't go slow. It was a fundamental mismatch of technology. Most backups are incremental backups. Today, more backups are incremental backups than ever before. And it was just a fundamental mismatch, and they had to find something better. And they were finding something better even before dedupe came along, right? We were starting to do disk staging and things like that. So the backup world went away from tape, because it was just really, really difficult to use for that. Not because it wasn't reliable, not because it was slow, none of those things, but because it was a fundamental mismatch of technology.
Yep.
Okay. So let's take those two facts. More tape is sold today than ever before. No one's using it for backup. So who's using tape?
I'm going to go out on a limb and say the hyperscalers.
Ding, 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 ding. Yeah, so it's the worst kept secret in the tape world that, Amazon, Google, IBM,
Microsoft,
thank you, Microsoft, are the biggest customers of tape. To which, again, many people would be like, what? Right? They're wait, they're the future, right? Cloud is the future. You're telling me that the biggest users of tape today are cloud? Really?
And I'm not surprised, right? Because everyone throws data up in the cloud. Everyone wants it to be the lowest cost possible.
Yes.
And the cloud providers, right, the hyperscalers are going to provide a service to meet the customer needs, right? Large amounts of data, low cost. What can they offer?
Yeah. Large amounts of data, keep it for a really long time, really low cost, and I'm probably not going to ever look at it.
Yeah.
Right? And so, yes, that stuff, like when you start talking about, and again, I can't speak specifically to certain products as to which ones use tape and which ones don't, but I can absolutely tell you that when we start talking about products like Glacier Deep Archive, those products are most likely using tape. And if you look at... Go ahead.
And what gets you to that conclusion, though? Maybe for people who aren't as familiar with Glacier Deep Archive?
Well, two reasons. One is the cost and the behavior of how things like Glacier Deep Archive. Again, I'm not speaking specifically about that product. I'm just using it because everybody knows its name. If you look at it, the retrieval time is very tape friendly. The normal retrieval time is very tape friendly. it's measured in hours, not seconds.
Yeah.
Right? Even the quick access is still measured in minutes, not in seconds. And so that's all very tape friendly. And all that is when you look at a gigantic tape library, it's just prioritization of requests is really all that is. It takes a couple of minutes to get to an object in the middle of the biggest tape that's out there, right? It'll take literally 10 seconds to get it from whatever slot it's in to whatever drive you want it to be in. And it takes an average of about 2 minutes to get to the file, no matter where it is on tape.
Yeah.
Right. And so it's perfect for tape. Notice that the service descriptions pay very close attention. They don't say anything about what they're storing it on. They're just like, you're going to give us a thing. We're going to charge you this much. You're going to agree not to ask for it anytime soon. Right. And if you do, we're going to charge you, up the wazoo for it. Right.
Now, I should preface this by saying you and I have no insider knowledge of what they actually do or how it's been built. It's just our understanding based on publicly available materials.
And I will say I have a tiny amount of insider knowledge in that I do talk to a lot of tape people, and they all tell me that, all these companies are their biggest customers. Yeah. They got to be using it for something. Yeah. This is what I think they're using it for. Right.
Yep.
And they probably also, and again, don't know this for sure, but they probably also are doing object level backup from a DR perspective, but don't know that for sure, right? So that's all to say that, the title of the thing is Tape Backup Dead? so we sort of, we're still in like the intro at this point, right? So let's go back to why tape sort of died in
everyday use.
In everyday, what I'm going to call operational backup and recovery. There's two reasons we, in the backup world, we talk about backup and operational recovery, which is I deleted this file. And then there's disaster recovery. Yeah. Tape still has a place, I think, in disaster recovery, much less of a place in operational recovery. So I'm going to give you an A/B question. A/B question? A multiple choice question. I'm going to give you a multiple choice question. The reason tape became a real pain in the butt in backup and recovery is that it was A, too slow, B, too fast.
Can I go with C?
What's C?
Pickles. No, okay. So I will tell you what I thought before you and I had conversations about tape. Right? My understanding at the time, it was that tape was too slow. That everything was moving way too fast, right? And that networks and disk and everything else is so much faster, and therefore tape died off, and therefore and that's why everyone switched from using tape to using disk. That's what I thought before we started.
That is, I'm so glad to hear that you have learned, the error of your ways. That is the most common misunderstanding of tape, right? Is that the reason tape went away is because it was too slow, right? The truth is actually the opposite. And what's interesting is it was somewhat of a self-fulfilling prophecy, right? Because people thought tape was too slow, they treated it like it was too slow, which then made it too slow. So let me explain what I mean by that. And I'm gonna tell a story. Okay. So large entertainment company, right? One that everybody would know who they were. They're still around. And they had, my memory is that they had about 20 terabytes of data that they were backing up. They had 18 tape drives running around the clock. They were literally like backing up like 28 hours a day. They were never finishing their backups. Not once were they ever finishing a complete backup. Yeah. It was a complete disaster. And I took a look at the numbers, and in 5 minutes, I knew what the problem was, and I charged them a crap ton of money to fix it, right? Their solution was to go buy more tape.
Which is what you would think, or tape drives, right?
Yeah, buy more tape drives.
Yeah.
Yeah. They were using the Storage Tech 9840 drives. And they said, we just need to buy 2 more of these things. We think that'll fix it, right? Because we're at 28 hours a day. We need to get to 23 hours a day. And these 2 drives will get us back, And those drives were expensive. They were like, it's like $20,000. It seems like per tape.
Which would be like $1 million
great.
today.
They were really expensive. What was that?
Which would be like $1 million today.
Yeah. This is a 15-year-old story. So I said, please don't do that, right? And then I basically, what I remember saying, I don't remember this, if this is 100% what I said was, give me that money, right? Give me that money instead of spending, $30,000 or whatever it was on tapes. Give me the $30,000 and I will guarantee that we will solve this problem. And we're actually we're gonna make it so much better than you could ever dream. And if I don't, you can have your money back. And you can go buy your stupid tape drives. And we went in there, and I made a bunch of configuration changes to their environment. One of them was they were specifically listing file systems rather than just saying this was a net backup environment, rather than just saying all local drives, right? And that's one of my pet peeves, right? Don't do that. Don't, because you'll miss stuff. Yeah. And I was right. They were missing 50% or 30% of their environment.
So now they needed 4 drives instead of 2 extra.
So they were backing up 20 terabytes. And by the time I had finished, tweaking the all local drives, they were now backing up 30 terabytes. They were missing 30% of their environment. And of the new 10, very little of it was true garbage. I was like, so what you do is you say back up everything and then exclude the things that you definitely know are garbage. We're going to exclude temp. We're going to exclude in temporary internet files and Windows and so on, right? And so we increased the amount of data that they were backing up. We increased it by 50%. They were backing it up once a day, not finishing it. By the end, they were creating 2 copies instead of just 1 copy. The backups were finishing overnight, meaning they were running in like 8 hours instead of 28 hours. And we were using 6 of the tape drives they had. So what I remember was of the 16 or 18, whatever the number was of the drives that they had, 6 of them were the newer 9840 drives. And then the other ones were the older drives. So I was able to retire the older drives. So go from 16 tapes down to 6 tapes, go from 1 copy to 2 copy, go from 20 terabytes to 30 terabytes. Did all of that by simply making configuration changes in the environment. And it all had to do with recognizing the fact that these tape drives were starving for data, right? Because as I illustrated with the VHS thing, tape drives want the data to go very fast. Tape drives have 2 speeds. They have stop and they have very fast, right? Now, that's a bit simplistic. There are some steps that different drives can do, but they do have a minimum, minimum speed at which they can go. And if you try to go slower than that, they cannot go slower than that. Yeah. So they speed up to their minimum speed. They write the data that's in the buffer. They turn back in and they look at the buffer, and the buffer's empty because you're not feeding the buffer. And then they stop and they have to back hitch, and they do it. And that's what they call shoe shining. Yeah. The tape drive, as a result, becomes slow. That's what I was saying. When you treat a tape drive like it's slow, and to make it faster, you buy another tape drive, you actually make the tape drive slower, right? That's what I meant by, because they believed it, they made it so. It's like a self-fulfilling prophecy.
So I definitely agree that's one of the problems with tape, or why tape sort of went away. But I think you had also alluded to sort of the problem at the start of the episode, right, where backups have changed formats to incrementals. And I think one of the challenges, speeding on to what you were saying with it being slow, is they're not able to feed enough data to tape drives when you're just doing incrementals.
Yeah. And, so my memory is that once we solved the tape problem, the world went to forever incremental.
Yeah.
Right. There was only one company that was doing forever incremental back then, and that was IBM with ADSM, which became TSM, which became Spectrum Protect. And the only way TSM would really work is if you did disk staging, right? So we just started moving slower and slower away from tape. And then once dedupe came on the scene, it solved the cost problem for disk, right? And then we just started moving off of tape as much as we can.
For operational recovery.
For operational recovery. So it turns out tape is actually way faster than we needed it to be. When we talk about data transfer rate, tape is indeed slow when we talk about random access. Tape is not random access. So if you need it to behave like an object storage system, which you could do it, right? There's LTFS. You can write to it like an object storage system. It's just going to be really slow when compared to anything other than tape.
Yeah.
And tape will become slow if you treat it like it's slow, right? And so there were all these design considerations, some of which we talked about in a few episodes ago, all of these design considerations that we did in order to, all of the contortions that we went through to make tape happy, right? What I found was that if you made tape happy, if you gave the tape drive the amount of data that it needed, then everything, literally the skies would open up, the angels would sing, the rain would go away, right? And the tape drives would also become more reliable because when you treat them like, they're shoe shining all day, they also become unreliable. They become slow and they become unreliable.
And you had that issue last year when you were dealing with the customer or with the client.
I did.
Right? Where
yes.
The tapes were not happy with you. The drives, in fact, would overheat. I think you had to replace them once or twice. They were not happy running 24/7 for months on end.
Yeah. And they weren't, and they were also being shoe shined to death, right? Because I was backing up across SMB over the network. It was just not good. And also you remember the core problem was that there were millions and millions of files.
Yep.
And so a lot of people went to disk, and specifically deduplicated disk and deduplicated backup services and and software. Like the first one I really remember was Avamar, right? Which for those that don't know, before it was Avamar, it was called Undo with 2 O's. They were invented. I don't know what the rate. They started creating Avamar like right up the road from me, like up in Irvine.
Yep,
that's where I first.
I've been to their offices.
Yeah, and they were like the first like dedupe backup software that was like right. And then I remember Commvault started adding it, Veritas started adding, and then you started getting these services that it's just a core design element, right? And as a result, tape just got smaller and smaller and smaller and smaller. Now, fast forward to today. Why would I want to think about tape at all, right? And so the title is tape backup dead? The answer is no, right? It's not dead. It is definitely on life support.
So,
but there are real reasons why we would want to use tape.
Yeah, and I know so far we've talked about operational recovery, right?
Yeah.
But one thing that pops to mind is disaster recovery.
Yes.
Right? How difficult is it for you to take a copy off-site when you are storing something on, say, a disk-based system? Right? Are you going to copy it onto disk? And I know there are companies that do like removable disk packs and things like that.
Yep.
But that's quite a lot of, like, physically, that's a lot to take with you, right? Versus,
Yes,
can I just take a small tape and then move it off site?
exactly. Because, and again, it's a phrase that some people use a lot. Never underestimate the bandwidth of a truck, right?
Yep.
Truck has unlimited bandwidth, really bad latency, right? But yeah, you can move an immeasurable amount of data via tape by going from A to B, right?
We used to call it also sneakernet.
Yeah, sneaker net's another, yeah, because it's going back and forth.
And
so before we get to that, I'm just going to try to summarize, and I'm sure we have an episode where we go into this in more detail. But let me just summarize sort of. I think it's going to be 3 reasons why tape is still, the value that tape still brings. One is you cannot beat the cost. It's not even close. I don't care the cheapest cloud storage, the cheapest on-prem object storage that you can buy. It will not even approach. It will be 1, possibly 2 orders of magnitude cheaper.
Yep.
It's just not even close, right? Go ahead.
When you say cost, are you talking the cost of the media, or are you including?
I'm talking everything.
Okay.
I'm talking fully burdened cost, including the cost of buying a tape library, powering that tape library, dealing with tape management, putting those tapes somewhere that's not the tape library because you didn't buy a tape library big enough, Iron Mountain contract, all of that. It's not even close. It will be 1, possibly 2 orders of magnitude cheaper than the cheapest alternative. And that's just a fact, okay? And one of the core reasons for that is that tape, unlike most other media, the media is separate from the thing that makes the media, right? That writes to the media. And because of that, the tape is so cheap in comparison to anything else, right? Right? So cost is number 1. And by the way, that includes power, that includes cooling, that includes all those things. That's, in fact, if I've made this claim before, if a disc was free, tape would still be cheaper.
I remember this
because of the power cooling.
Yep.
Okay. Which means it's also greener.
Yep.
For those of you that care about those things, it means it's also greener, right? So it's cheaper. And then these two will surprise probably. Okay. I remember. Okay. So I came up with a 4th reason. So second is that it's faster, right? It's faster if you need to transfer a crap ton of data from A to B, it's faster to write it to tape than it is to write it to any disk on the planet. I don't care which disk we're talking about. I don't care if we're talking solid state, rotational disk, whatever it is, just from a transfer rate perspective, tape is faster than disk. It's without question. Okay, number 1. Number 2, and then when we start, the thing that you brought up, when we start talking about bandwidth, right? Tape has unlimited bandwidth.
Yep.
Right. And then the 2 that I think will actually, and by the way, I think that one will surprise a lot of people too. But feel free to check me. Better check yourself before you wreck yourself. Tape is also better at writing 1s and 0s than disk is. Tape is also better at holding on to 1s and 0s than disk is.
By a significant,
multiple orders of magnitude.
Yeah.
Right. So this has to do with something called, the first one has to do with the bit error rate.
Yeah.
So for every 10 million zeros that you write, you're going to write 1 wrong. I'm just making up a number there. But that's somewhere in there. It's 1/10 to the 15th or something. Yeah. Right. That's there's when we look at disk and there's SATA disk, fiber channel disk, and then we start talking about solid state disk. Each of those in order, those are better at writing 1s and 0s. But when we get, and it's and I can't do the last time I looked, it was 10 to the 14th, 10 to the 15th, 10 to the 16th. when we start looking at like SATA, fiber channel, and SSDs. But at that point, the worst tape drive was 10 to the 18th. The best tape drive was like 10 to the 20th. That means it's what would that be? That means it's 10,000 times better.
Yeah. Oh, sorry. 10,
right? Because it's 4 zeros.
Yeah.
It's 10,000 times better at writing ones and zeros than disk is, than the best disk.
Yeah. And that's, and like you said, that's just writing the
That's
bits.
just writing it.
Yeah.
Yeah, the first time. Because every time you write ones and zeros, some of them are going to be written wrong. Yeah. This is why we have ECC. By the way, this is after ECC. Right? That's error correction codes. So it's better at writing the ones and zeros in the first place. It's also better at storing the ones and zeros for long term. And that was what we had Joe Jernicke to talk about. Something called bit rot.
Yeah.
And that's the vernacular term. But
coercivity of
what? Coercivity.
Yeah.
Coercivity. It comes from the idea that a 1 could be coerced to be a 0.
Yeah.
Right? Over time, based on heat and the size of the grain. Bigger the grain, the better. The cooler the media, the better. Tape has gigantic grains in contrast with any other magnetic media. Mm-hmm. And tape is stored in ambient temperatures versus disk that is typically very, very hot all the time. Yep. You can play with it a little bit. It's a formula, KUV over KT. You can play with it a little bit when we start talking about things like MAID, where they power off some of the disks. Mm-hmm. That will extend the life better. But tape, by design, is kept cool, unless it's being used.
You're not going to keep it in the back of your car. Or you shouldn't keep it in the trunk of your car.
You shouldn't.
In the middle of summer in India.
Exactly. And so those are 4 reasons: cost, speed, what would you call that? Integrity, initial integrity, and long-term integrity. Those are the 4 reasons why you might want to think about tape. Now let's talk about the 5th, which is really to go back to what we were talking about before. You brought up about DR.
Yeah.
What would be the additional feature that tape can bring when we start talking about DR?
You can basically just copy it, ship it off somewhere else, and just leave it there. And if something happens, you have that copy. It's low cost, like all those 4 factors you talked about before, right? You know it's going to be there ready for whenever you need it. You could pull it back, you could restore it, and you can get going again.
So that is true. That isn't where I was going, but that is all true, right? So because that means it is easy to put it somewhere else.
Yeah.
Right? Because of that unlimited bandwidth, because you can, hand it to a FedEx person and magic happens and it just shows up in another place, right?
What were you getting?
What is the number one reason that people are currently doing disaster recoveries?
Oh, ransomware, because it's air.
Ransomware. Tape is very ransomware proof.
Yeah.
Right? When we talk about ransomware a lot, we talk about immutability, right? Mm-hmm. What is immutability, Prasanna?
It's once it's been written, it's how difficult is it? Well, it shouldn't be able to be erased or modified or changed.
Correct.
Before a certain period of time has elapsed.
Yeah. That's what immutability means. And tape is, by design, tape can be made to be literally immutable. Like even in the drive, it cannot be overwritten, even if you've got physical access to the drive. It's a truly immutable medium. And so, and even that feature aside, it's a tape sitting on a shelf. Yep. Right? And maybe even in a, you can secure it as much as you want to secure it. You can put armed guards in front of it, right? Go ahead.
It does have a fatal flaw.
Talk to me.
Magnets.
Okay, for the record, it has to be really, really strong magnets. It requires, so speaking as, I work for a company, one of the things that we do is data destruction. It requires really big magnets in order to degauss would be the term, to degauss a tape.
Which is the same thing with hard drives, right? If you get a strong enough magnet, you're going to have the same issue as well.
Yeah, exactly. But it's a 100% immutable copy that is easy to get very far away from here, right? You can have somebody completely outside of your company holding on to it. You don't need to power it. This is, I think, the number one use case for tape in the backup and disaster recovery arena today is DR, especially defense against ransomware.
Yeah. And you don't even need to ship it outside your site if you don't want to, because of the fact that it is an air-gapped copy that is typically not available on the network.
Well, I'm going to say for ransomware purposes, no.
Yeah, for ransomware.
But when we start talking about the other things, we do want that one copy somewhere else, right?
Yep.
What was the OVH?
Yes.
Just go listen to the episode on the OVH disaster where they took out the fire, the very intensive fire, took out both the data center and the place where the tapes were because they were all in the same place.
Yeah.
I remember the first time I went and I saw someone else talking about backups and they were talking about tape. The title of the presentation was something along the lines of like, why tape sucks for backup. And it was this guy that had made a bunch of tape backups and he had put them in a box and he had put the box on top of the server and the server had caught fire and it had taken the tapes with it. And that's why tape backups suck.
So there's a story I have where someone you and I know was a developer working on a product for tape.
Yeah.
And he would basically write the data out to the tape. He would take it out of the tape drive because he was doing some testing, and he would put it on a shelf.
Yeah.
And then he would go read the tape again, and he'd have issues. He's like, what's going on? And he kept thinking, oh, it's my code, it's my code. He kept debugging it, taking every look at everything. So apparently the shelf he put the tapes on, underneath that was one of those lights, and it stuck onto the thing with a magnet.
That's pretty funny.
Yes. So that was my first intro into tapes.
Is this a guy that rides his bike to work a lot?
Yes.
That's what I thought. Okay. Yeah. So I know who you're talking about. Yeah. Anyway, interesting. I'm trying to think if one of the cooler stories that I remember that was like that was that there was an offsite like a what do we call it, the robo, right, remote office branch office, and the solution for that particular office was they didn't have any IT people there, and so they had a security guard whose job it was to take this a case that was designed to hold a single LTO tape. Take out the LTO tape, put it in the case, FedEx the case back. They would FedEx the other case back, and this is how they did offsite tape. And it was months later that they found out that he just found it easier to just not put anything in the case. And so they were just shipping empty tapes back and forth.
Oh, no.
Yeah, the way they where they proved it, nobody thought to look at this. Nobody ever opened the case.
Yeah.
Right? And so what they did was they went and they looked back at the FedEx. The weight is always so he had never ever put a tape.
Oh no.
In the another one that I remember was this woman that worked at this was at a large aerospace company, and they had a system where, again, there were no IT people, but there was a tape there, and they would eject the tape, and she was supposed to pull that tape out and put another tape back in. She just kept pushing the tape back in. Oh. And so they had backups, but they only had the latest backup.
Yeah.
Right? And at the time, that turned out to be a problem.
Yeah.
So, yeah. So tape backup is not dead. I will. I now know there was something a point that I wanted to make. While it is difficult, near impossible actually, to do incremental backups directly to tape, even if what we're talking about is incremental backups, once they have been copied to some kind of disk medium, copying those backups to tape should be easy peasy, right? Because you should be able, and that can be built into the design. You can figure out what's the speed of the disk, right? And what's the speed of the tape, and you can match those. That should work. You can build that into the design and make sure that you've got enough sufficient transfer speed. Even if it's incremental backups, it doesn't matter. It should transfer to tape, no problem. And so that's what I meant earlier where I said, when we back up to disk, I think the primary use of tape today in backup is that second copy. Mm-hmm. Because if we're using, let's say, a big dedupe box for our operational backup and recovery, it's very easy to make a copy from that dedupe box to tape and then ship that tape. Even if you never use the tape, it's still easy to do that on a pretty regular basis.
Ooh.
What is that? What is this face?
No, I would never. Sorry. Depending on the architecture of the deduplicated appliance and how it's configured, doing reads from disk to take that backup and run it off to tape could be painfully slow, and slower, in fact, than your initial backup speeds.
As I mentioned, it should work. You need to figure it into the design. You may find that the dedupe box that you want to buy, or one that you already own, that the speeds with which I would argue that if it's truly that slow at transferring those backups out to tape, it would also be truly slow when doing a recovery.
Yep.
Because the operation is identical. And so if that is a problem with your dedupe device that you are using, then you need to address that.
Yeah.
Yeah. So we're on the same page there, I think.
Okay.
I was telling you about that. I was telling you yesterday. I was talking about that box that I worked with 100 years ago, where this was a long time ago. The aggregate backup speed, to back up to it, or write speed, I guess you would say. The aggregate write speed was 400 megabytes per second. The aggregate read speed, so no matter how many backups no matter how many restores you ran, it was 40 megabytes per second.
Ouch.
And they addressed that in later designs of that particular product. But you cannot assume. Not only can you not assume, you should probably assume the opposite. Yeah. You should probably assume that read speeds are going to suck because of the way that some dedupe data gets written down to disk. Okay. So tape's not dead. Not going anywhere soon. It's still the cheapest, most effective way to transfer data around. Also great about storing data in the first place, holds on to it. You just have to build that into your design from a backup and recovery perspective. And so most people, when designing backup systems today, don't use tape certainly not as the initial copy, but they might use it as a secondary copy. And I have no problem with that.
Yeah.
Any final thoughts from you?
The only comment I had was when we were talking about the hyperscalers and their use of tape and offering this low-cost storage.
Yeah.
I know we always talk about throw the data in there and never touch it, because that's probably what you're going to do. But please make sure you at least test it before you make that conclusion, because you want to at least understand, because as we're talking about the restore speeds of that appliance you were talking about, right? I was like, oh yeah, people should probably test what the restore performance looks like from that copy if they are using cloud or deep archive storage in the cloud, just to make sure they understand the performance of that.
I don't have any problem with that comment. I would say that's probably true of all parts of IT.
Yep.
Right? Anywhere, especially anywhere where you're storing data. So thanks, Prasanna, for the conversation.
Okay.
You're hilarious. And thanks to our listeners. Make sure to subscribe so that you don't miss an episode. That is a wrap. The Backup Wrap-Up is written, recorded, and produced by me, W. Curtis Preston. If you need backup or DR consulting, content generation, or expert witness work, check out backupcentral.com. You can also find links for my O'Reilly books on the same website. Remember, this is an independent podcast, and any opinions that you hear are those of the speaker and not necessarily an employer. Thanks for listening.